Okay, guys. What we have here is express x in terms of p and q. Okay, express x in terms of p and q. Q squared x equals p plus 2q squared. What's stopping the x from being on its own? Where can we bring the q squared then? P plus squared all over. Okay, that was easy. Now, what's the next part? If y equals q bracket x minus 4, show that y equals p minus 2q squared over q. That's very interesting, okay? Now, currently speaking, y and p aren't in the same equation, are they? We have two pieces of information. The first equation we have to work with is this one here. That's the first equation we have to work with. The second equation we have to work with is this one here. So see the two equations in the two green boxes? They're the equations we're allowed to use. Okay? This equation that I'm now going to put in the pink box, that's what you have to prove. See the word show that? Means I can't use it. I have to create that one. Okay? So what we're looking at is y has to be on its own. Do you see the way y has to be on its own? Okay. And it is, thank you, good call. Y is already on its own and it's equal to qx minus 4q. You happy enough with that? Which letter is currently in this one but is not in this one here? Which one? X. X is the one we need to get rid of. Is there anything that will get rid of x for us? Is there an equation that has x on its own? It's looking at us right in the face. It's in the big green box, right? So x is on its own. Y equals q times whatever x is. P plus 2q squared all over q squared minus 4q. Now, okay, think we can get this, okay? Now, can anybody tell me what happens when you multiply, as an example, right? If I had 3 multiplied by 4 over 3 squared, could anybody tell me what happens here? What can you do with the 3's? In a way, see the way it's multiply, and it's what I was discussing with Rory earlier. If I technically multiply top by top and technically bottom by bottom, it's 3 by 4 all divided by 3 squared. Are you happy with that? And see the way the 3 here can cancel with the square down there. For what you say? Why can I cancel the squared? Okay. 3 squared. Would you agree that 3 squared is the same thing as 3 multiplied by 3? And because the 3's are multiply on the top and the 3's are multiplying by everything on the bottom, they're available to cancel each other out. That makes sense? Now, in the same way, why did I show you that question? It's the same thing over this side. This q is available to multiply by everything on the top. So it's technically q is getting multiplied by everything inside that bracket. On the bottom is q squared, which is q times q. What can I do with the two q's? Cancel them, okay? Now all of a sudden I'm going to have p plus 2q squared all over q. What can you tell? What's the problem with the 4q? Do they have the same denominator? No. So put an extra 1, top and bottom. What's 4q? 4q squared. Finally, what's 2q squared minus 4q squared? All over q. Is that what I was asked to prove? Yes, it was. Okay, done. Okay, so that's a good question. Ready to move on? Now, question 20. Express L in terms of T, K, and G. If I told you that x equals root 16, yeah? If I square both sides, what happens? X squared equals 16. If you square a square root, it gets rid of the square root. And if I square the letter, it just becomes that letter squared. If I do the same thing to both sides, balance is maintained. What I'm doing is I'm multiplying both sides by themselves. Okay? So, what happens here, guys, is I look at this and I go, the letter I want is the L. The L is locked in front of a square root sign. Okay, now I want to try one other thing, which is alright, before we go to this. If I said y equals 3x, okay, technically speaking, what's y squared? You're missing a small bit of language. 3x, 2b squared. You said it's this one here. Well, 3x 2b squared is inside a bracket squared. And what does 3x 2b squared mean? So technically it's 9x squared. Is everybody happy with that? Now if I gave you another question like this, what's y squared this time? You have to square the full thing, don't you? So get rid of that. Y equals 3 root x. What's y squared then? Huh? Now, remember what you did last time? You multiplied 3 by itself, didn't you? It was 3 by 3 last time. This is no different. It's going to be 3 root x multiplied by 3 root x. 3 by 3? 9. Root x by root x? No. Any number that's a surd, multiply it by the same surd, is 5. In the same way, root y by root y, y. Root 10 by root 10, 10. Perfect. So it gets rid of it. So what happens then? Root x by root x. There you go. Is that alright? We apply this logic into the question to the left. Square both sides. Square the left side. Square the left side. T squared. Square the right side, it appears like this. Now, let's concentrate on what we did down here. Instead of 3, we have k. What's k times k? Okay, so we've taken care of the first part. We used to have root x by root x, and that turned into x. This time we have root L over G multiplied by root L over G. So what did that turn into? L over G. It doesn't matter how complicated the square root is. When you multiply a square root, it doesn't matter what's in here. If you multiply it by the same number, or the same type of number, it will just turn out to be whatever is in the box. Does that make sense? So, which letter do we want on its own? We have here then is this G. Can somebody tell me another way to write this whole part here? What way could I write that? Remember, it's multiply, not addition. So what do we say about the denominator on the bottom? All over G. Because it's multiplication, the denominator on the bottom can be written underneath both of them. Okay? If it was addition, would I be able to do that? No. Okay, which letter do we want on its own? L. What's stopping the L from being on its own? It's being multiplied by k squared, so when the k squared crosses the equal sign, where does it appear? Under the t squared. And finally, the g is currently being its division, so when it brings it over the other side, t squared by g over k squared equals L. Everybody cool with that? Okay. Now, question 22. If px minus b equals a minus qx, express x in terms of a, b, p, and q. Which letter do we want on its own? X. How many x's are there? There's two of them, isn't there? Anything that has an x goes to the left. Anything that hasn't got an x in it goes to the right. So, left, right. Px plus qx equals a plus b. After that, guys, x bracket equals a plus b. Finally, good man, a plus b over p plus q. How do you write that question? What do you think of it? Easy, hard? Alright, it should be medium. Okay, medium to easy. Now, going to do next, guys, is hence. Now, what does the word hence usually mean in regards to the previous question? Use information from the first part to answer the second part. Okay, we're told that root 2p equals 4a, and then we're told that q equals minus 8b squared, and then we're given all this here, and you're like, how do you make heads or tails of that? How on God's green earth do I even start that? Here's how you. Now, it used to be really difficult for me as well, but I learned the one trick is really simple. Okay, see the way x is more or less on its own, except apart from the 8. Yeah, I look for something similar. I would personally look at this one here. Does everybody understand why it's a good starting off point? Because all what I'm missing would be an 8, isn't it? Now, I look at the x, and I look at the x here, and then I look across at the other letters. This only wants a's and b's present. Do you got that? A's and b's present. What two extra letters do I have? I have p and q. Okay? P and q are extra, and I don't want them. If I get p on its own, and I get q on its own, I can substitute them out of the equation, leaving only a's and b's. That's my plan. So here's my first equation. Root 2p equals 4a. My logic is I want to get rid of the p. How do I get p on its own here? What's the first step? What's the first step to getting p on its own? Just for this one equation here. How do we get p on its own? It's a square root sign, guys. How do you get rid of a square root sign? We did it earlier. Square both sides. And what happens when you square both sides? What happens to the 4a squared? 4a 2b squared. 16a squared. What happens to the root 2b squared? It's root 2b by root 2b, which is perfect. Okay. Finally, to get p on its own, 6 divided by 2, which is 8a squared. Thank you. Okay. So 8a squared. So, first thing I've done is I've replaced this x is now a plus b, and I've forensically got rid of the p. The p has now disappeared, and it's 8a squared. It's looking more and more like this one here. Only letter I have to get rid of next is the q, because the q is not in the answer I'm looking for. I go to the equation that has the q in it, and what do I do here? Is q already on its own? Alright, q is already on its own. Perfect. So all I have to do is just put in what q is. Minus 8b squared. Still doesn't really look like the one we have up here, does it? Not yet. Okay? Doesn't look like it does yet. So what we're going to do is we're going to have a look and go, okay, it doesn't look like that one there. Am I fully factorized? Okay, I'm not fully factorized. So 8 brackets minus b squared. This 8 is division on the right, which means when it goes to the left, multiplication. 8x. Getting very close now. And what about the a squared minus b squared? The a squared minus b squared out? What is it? No, not multiply. It's a factorized question. Difference of Two squares. A plus B. Don't move till I give you your homework. A minus B. A plus B. The A plus B's. 8x equals 1 over A minus B. Proven, okay? I did questions 22, 20, and 17. Okay, 1 second.